All right, I think we'll go ahead and get started. Good morning. My name is Jarma Bennett, and I work in the Office of Information Management here at the State Water Board. Thanks for joining me today for this data workflow workshop. The purpose of today's workshop is to provide space to discuss various data workflows through an equity lens. We will be hearing from two different projects today. We were going to hear about from a third, but the lead of that project, Reed Hishofsky, is unable to present today, so we hope to hear from him in a future workshop. After we hear about the two projects, we will open it up for questions and discussions. Before moving into the main topic for today, I do want to plug the College of Water Informatics. Water Informatics is the interdisciplinary science focused on the collection, storage, analysis, and communication of water data and information. The College of Water Informatics was launched here at the Water Board in 2021 to deliver data literacy training and resources. And this workshop is being recorded, and the recording will be posted on the College of Water Informatics website, which I've put into the chat. And so it will be part of that outreach effort. As I mentioned, we'll be taking questions at the end, but feel free to add your questions to the chat so you don't forget them. And remember to keep yourself on mute so there's no background noises to distract other people. And now we're going to turn it over to our first presenters. They are Devin Burke and Leah Jones. Thank you, Leah and Devin.
Yeah, thanks, Jarma. Thanks, everyone. Excited to be here. Leah Jones and myself are part of the Cal EPA Racial Equity Data Team. Leah Jones is the team co-lead from the Central Valley Water Board's planning section, and I am from the State Water Board, also at the Office of Information Management and Analysis. Today we'll be discussing our workforce equity, our markdown tool. What really drove the need to create this tool was to provide something that was customizable, featuring metadata and graph demographics of statewide and departmental workforce. Next slide. To give some additional background on our tool and why we compiled workforce data, we wanted to really establish baselines for performance measures and racial equity plans, provide customizable slide decks featuring various demographics that could be used and edited by various agencies. And then we wanted to provide a tool that characterizes workforces and informs on question-driven approaches in early stages of normalizing conversations around race. I also provided some resource here on the Government Alliance on Race and Equity, GARE, which uses the change model, which is the basis for part of our tool as well for normalizing, organizing, operationalizing. Next slide.
Devin, you started out really loud, and then in the middle of what you're saying, it got quiet again. I don't know if something changed on your end.
Uh-oh. Is it bad?
It's medium now. That's better than at the.
Okay, I'm gonna come closer.
Okay.
Sorry, everyone. Okay, so to reiterate, I'm not sure where I kind of went off on not being heard. Do you want me to go through the full slide again? Yeah. No. Okay, next slide.
Yeah, it just got low, but I could still hear you. Hopefully everybody else could too.
Okay, apologies. Okay, so thank you. So jumping into our first stage of our data workflow, we wanted to highlight where our data comes from. So basically, surveys are provided to state employees that generate data on racial identity. There is a caveat that there are blank responses. So if you leave something blank when identifying your race, that gets filled in by supervisors and HR on their own discretion. Data is submitted annually to the State Controller's Office for the calendar year. The deadline is June of the following calendar year. And then the data is published by CalHR as 5102 reports in the form of tables. You'll hear us refer to these 5102 reports a lot in our presentation. So to be more specific, they refer to the state employees by occupational group and classification, which is a biannual report and captures the race, ethnicity, gender, disability, and veteran statuses by occupational group and classification for all state employees. These tables are then transformed into machine-readable data sets by CalHR staff and sent to our Cal EPA Racial Equity Data Team. The machine-readable data sets are then published by the state water boards as open data and used in the workforce equity tools that we'll be talking more about today. They're then uploaded as well to the open data portal and GitHub. Next slide. Okay, so continuing for our data flow workflow stage 1, as previously mentioned, the water board, specifically CalHR, compiles and cleans the 5102 data reports into tables as part of the data cleaning and exploration process. This is done in Excel, and the tables are published as open data. Here's an example of what the machine-readable data tables look like when we receive them right before they're published. Next slide.
Thanks. So moving on to stage 2 of our workflow, we clean and explore the data using RStudio, which is a software, R being the language that we code in RStudio, and the result, the tool is published as an R Markdown document. R Markdown is a file format to make dynamic documents within R. So it's written in a plain text format known as Markdown, but it contains chunks of embedded code. So people can, and the result is what you see there on the right. That's a screenshot of the beginning of the tool. So you can scroll through it just like a document, but there's code chunks in there and the plots created by the tool. So the first part of the document is the introduction, which provides the user with helpful background on the tool and the report and the purposes of the workforce demographic data as Devin outlined. The next step in the process is loading in our packages. Primarily, we use the group of packages from Tidyverse, which includes packages such as Dippler and ggplot2. We also use the package Tidy Census in order to pull data from the US Census Bureau. Next up, we enter the parameters for the document and the tool. This is where the users can modify which department and year they want to visualize, as well as changing the titles of the plots. The next step is loading in the data. So as Devin mentioned, we use the 5102 report from CalHR. We pull the clean version, the machine readable version of the data from the open data portal within the document. And then we also use the American Community Survey from the US Census Bureau, pulled using the an API key in the Tidy Census package. If I say census data or Devin says census data throughout this presentation, we're referring to the American Community Survey. We use that data because it's a survey that's done every year to represent social and economic demographics of populations, but the census is only once every 10 years, so this is a helpful comparison for our purposes. The next step is transforming the data, where we modify the variables to match between the two data sets so we can compare them on graphs, and we also filter for what department and year that we want. And then finally, we build the plots. So shout out to David Altair, who will be talking later. He definitely was a huge collaborator in this process and coded the functions to build these plots. And there's code at the end of the tool in the Markdown for the user to save the graphs as PNG files, as well as some metadata and additional helpful links and resources at the end. Next slide, please. So we're going to show a few examples of some of the plots that are made by this tool. Some things to note on this slide is one of the ways that we decided to visualize the data was splitting it up into what we call level 1 and level 2 ethnicity. Level 1 is what you see here on the graph. So it's just grouping together the ethnicities of white versus Black, Indigenous, people of color, or BIPOC. And then level 2, which you'll see next, matches the ethnicity groupings of the American Community Survey. So it breaks it down a little bit further. We also have the option to show this as a stacked or a group bar graph. This is an example of a group bar graph. The stacked you'll see next is like a percent of whole. And then this, here you can see we compared the department workforce to state population, and this is for 2020 for Cali, PA. Next slide, please. So this is an example of a stacked bar graph showing level 2 ethnicity. And another thing to note on this is we have it broken down into classification groupings, which can be customized in the code. And for the purposes of Cali, PA, this is specifically State Water Board. We broke it down into administrative, legal, management, and technical. So we hand selected what those groupings should be. As a general finding, we found that there was more diversity and representation in administrative classifications than the technical, legal, and management classifications, which does have a lot of implications in equity, especially when the administrative classifications at the lower ranks are traditionally among the lower paying classifications in civil service. So definitely a lot of implications there. And I'll also note on this slide that we have other tools that visualize the workforce on more specific categories. So the 5102 reports provided by CalHR break down the ethnicity groups even further. So I think they have like 5 broken down in just within Asian. But for the purposes of this tool, we're comparing to state population. So we grouped those together in order to visualize here. But we have other tools that show the full range. Next slide, please. So this is the last graph that we'll show, just another example of what's provided by this tool. This is an alternate way of viewing the data to compare multiple departments at once. So here we have all of the BDOs and Office of the Secretary. So again, the user can customize this. And next slide, please. So all along the way, we are using GitHub. GitHub is an excellent platform and online hosting service for open source software development projects and version control. So Git is the version control system that allows us to track and manage changes to the code. Think of like track changes in a document, but with our code. It also allows anyone who's in this repository, which is the name of this thing that houses all of the files and the code. It allows anyone who has access to make changes and push the changes and see what other people are doing in there. So it's an excellent way to collaborate, especially when working remote. It's been really helpful. It also allows external collaboration, so anyone can come in here. This is how external folks can view the tool. They can download the tool and modify it for their purposes and use it however they want. They can also fork, as you can see on the upper right of that screenshot. It's really small, but there's a few different things they can do. They can watch, which means they can get notified if there's any changes to the code. They can star, which is basically just liking it. And then they can fork, which means they can build off of this repository into their own profile and their own repository, make changes there without modifying ours. And hypothetically, they could also make changes and then submit them to us for review if they wanted to. No one's done that yet, but it's a really excellent way to collaborate that hope to utilize more in the future. Next slide, please. So as a summary, this is kind of the data workflow as a whole. Stage 1, the data cleaning and organization. Stage 2, processing, reporting, visualizing, and ongoing using GitHub to host our data, host the code, collaborate, and track changes. And it's kind of an ongoing process. Like every year when the new 5102 report comes out, the data has to be updated, and then if any changes to the code need to be made, then we make that. So it's kind of like an ongoing cycle. Next slide, please.
Okay, Lastly, we wanted to touch on the limitations of our data and tool. So it's important to note our tool does not disaggregate by divisions, offices, regions, branches. Department means they're all aggregated together. There are mandated identity variables that are not uniform with one another for comparable data sets, for example, the American Community Survey. There are also unknown errors due to how blanks are handled. As mentioned previously, supervisors and HR have their own discretion and are basically relied on to fill out blanks to their best knowledge. There's no real steward due to data flow at this current time. And then at the beginning of the year, there's a new process that allows each person who is essentially identifying their race to check as many boxes that apply. And so when we are reporting or categorizing that data, we'll have to organize who's selected each race in combination with others, as well as folks who have just selected one race. And then obviously users need basic skills in R, RStudio, and GitHub. Thanks.
All right, thank you, Devin and Leah. As we said, we'll take questions at the end. So now we're going to move on to our tribal water data project presented by David Altair and Michelle Tang.
All right. Hi, good morning, everyone. My name is Michelle Tang. I'm an environmental scientist in the Office of Information Management and Analysis, or OIMA, and I worked on the Tribal Water Data Project along with David Altair, who's a water resource control engineer, also in OIMA, and Alexis Perez, who was our 2022 Summer Fellow, also in OIMA. So David and I will be presenting the workflow for the Tribal Water Data Project. But before we kind of dive into the workflow side of things, I do want to provide a bit of background about the project. So this project is essentially an interactive tool that we built using R Shiny. And we built this tool for OPP, the Office of Public Participation, to help them compile information that would go on to inform their outreach efforts related to drinking water issues in tribal areas. So in a nutshell, how this tool works is that it maps two tribal boundary data sets, and it finds the intersections of those boundaries with three other data sets, which we'll be talking about in this presentation. And then we've identified or highlighted those tribal areas with the most intersections to be those potential priority areas to which OPP could direct their future outreach efforts. Next slide, please. So the topic of this workshop is data workflows. So here is a high-level overview of what our workflow for this project looks like. We split it up into 4 main sections or topics. And within each one of these boxes, we put the icon of the tool or the software that we use to complete that part of the workflow. For the rest of this presentation, David and I will be covering all 4 of these topics and discussing them in a little bit more detail. And David will start us off with the first topic, which is data exploration.
Thanks, Michelle. So when we started this project, based on our discussions with OPP, we identified kind of 4 main categories of data that we knew we would need to include in our analysis. So that includes the tribal boundaries themselves, as well as data about mobile home parks in California and domestic drinking water wells and water systems. So when we started, we weren't really sure exactly where we were going to find the data sets to cover any of these particular topics. So the first phase of our work is really just kind of casting a pretty wide net and doing a lot of research to find potential data sources. So if you can go to the next slide. So you've already heard a little bit about our Markdown, but we also use that in this project to kind of help us organize our sort of research and data exploration process. So again, just to reiterate, our Markdown lets you combine narrative text along with code like R, Python, and then you can render that into a variety of different reporting formats that also include the output of whatever code you've included. So on the next slide, you can kind of see what that actually looks like in practice. On the left is the actual markdown file that you would work with and edit as you're going along. And then on the right is the rendered sort of output report version that you can share. In this case, it's an HTML file that it's rendered to. So on the next slide, we used R Markdown for kind of a couple different purposes in our data exploration phase. First was just simply maintaining a list of the data sets that we found that we might possibly want to use. So here you can see an example where we found a bunch of different data sets for tribal boundaries and just kind of kept a running list of those. And then next slide. We also used R Markdown to document how to actually access those data sets. So on the next slide, you can see an example where we used an R package called Tigris, which is actually pretty closely related to the tidy census package that was mentioned earlier. But we actually used it in this case just to access some administrative boundaries directly from the Census Bureau. And then on the next slide, also kind of a neat package that we found is an R package called Esri to SF that lets you pull in data from an ArcGIS server directly into R and makes that process pretty easy. It's something I've always had a little bit of trouble with, so that was really useful. And then on the next slide, we also used R Markdown to just capture some of the basic data exploration and validation that we did. So here you can see an example where we just made a pretty simple map, but we've got the code to make the map as well as the output of that code itself all contained in that same document. So it just helped us to kind of get a quick look at what's actually in those data sets and see if they were useful for our purposes in this project. And then on the next slide, actually also wanted to mention another R package that we used called SF that we really used sort of throughout this project. And it gives you a lot of really useful GIS type functionality for R. So we use that really through all phases of the work, including in the final Shiny app that we're going to talk about later. And then next slide. So finally, we used R Markdown just and more generally to keep notes about the data sets that we found. So things like differences between similar data sets that we found, or notes about the limitations of a particular data set, or just questions or ideas to follow up on. So in general, this was really useful for us because we had a couple of different people on the team and we were never really working on it concurrently, and it kind of stretched out over a long time. So having this kind of centralized location where we could keep all of our sort of research findings was really helpful to keep everybody on the same page and just, ensure that we didn't lose any of the work that we had done. So now on the next slide, I'll pass it back to Michelle to talk about some of the data processing that we did.
All right, thank you, David. So for the data processing side of things, actually, the majority of data sets that we worked on didn't require a whole lot of additional processing aside from what David did during the initial exploration and validation phase. The one exception to this, however, is the mobile home parks data set. So we did have to put this data set through a couple of steps in order to use it in our reporting tool. So the first step was obviously to download the data. So the data set came in the form of an Excel file that we downloaded from the California Department of Housing and Community Development website. We then imported and wrote a script in Python to clean and process that data. So this Python script does a couple of things. It does some basic operations like text character validation, renaming columns, breaking up one column into multiple columns, But in addition to that, it also handles some mobile home park addresses that we had some issues with trying to map later on in the process. So we actually had to kind of identify, pinpoint those addresses, correct them within this script before moving on to the next step. Next slide, please. And then our third step was to convert the park addresses to geographic coordinates. So an important thing about this data set is that when you download it from the state agency website, it includes the street addresses for each of the mobile home parks, but not the geographic coordinates. And for those familiar with GIS or any type of web mapping application or tool, typically these tools can't plot points on a map just based on the street addresses as they are. Typically, they're looking for the geographic coordinates, which are those latitude and longitude coordinates. So that process of converting the street addresses to geographic coordinates is called geocoding. And we geocoded the mobile home parks data set using ArcGIS Pro and a pre-made geocoding toolbox that was developed by our Water Board's GIS unit. So this toolbox can be found on the GIS unit wiki, and I've provided a link to that on the slide here. And it's really helpful because it's available for all Water Board staff. You don't have to worry about any additional licensing aside from what's already there with the ArcGIS suite. And from there, we could convert the addresses to those geographic coordinates and plot a map like what you see on the left there. Next slide, please. So after we collected and prepared all of our data sets, the next step was kind of the reporting and visualization phase of things. And as I mentioned at the very beginning, we did end up creating a R Shiny interactive tool. And R Shiny is a platform that you can use to create web applications using the R programming language. And when we were building and designing this tool, our main objective was really to be able to identify those tribal areas with the greatest need for outreach. And again, this is based on the counts of those intersecting mobile home parks, wells, and water systems. So as you can see on the right, we included several elements of this tool. We have a map, we have a bar graph, we have a table, we have some select menus for filtering and changing data sets. All of these elements are interactive and they interact with each other in different ways. But really what this tool kind of does is it pulls together all those data sets that we talked about before and makes them available on the single platform where the user can go in and explore all these different data sets in different ways. Also, the analysis that's done for like finding those intersections and identifying those tribal lands with the most intersections, all of that is done in the app as well. It's all done on the fly, so you can change which tribal boundary data set you're using on, see the results of that, and see the results displayed in many different ways. We've also included some functionality for the user to be able to download the data directly from the tool. So there is a download button where you can export the tabular or attribute data and use that offline however you wish. Next slide, please. And then last but not least, collaboration was a very big part of this project. And just between the three of us, David, Alexis, and myself, we all, brought different things to the table. We have different backgrounds. We use different programming languages. We have different preferences for the type of tools that we like to use. So it was very important for us to stay organized. And GitHub was kind of that main platform that we use to facilitate this collaboration and staying organized. And it was such a useful tool for just having this central location where we could upload all of the latest work that we've done and then also keep track of what each one of us were doing and what changes that we were making to each file. It also made it easy to go in and download the latest work from our teammates to ensure that we were always working on the most up-to-date files. Next slide, please. And that's all that we have for our presentation. Again, just kind of wanted to show this slide to give that big picture overview of what our workflow looks like and the different type of tools that we used. I know we kind of have to cover things pretty quickly, so if anyone does have any questions, we'll be happy to answer it during the Q&A session. But yeah, that's all we have. Thank you very much for your time.
Thank you, Michelle and David. Yeah, it looks like there was a lot of collaborating and documenting, so that's good to see using GitHub for. We do have a couple of questions already in the chat. One that was already answered, but I'll go ahead and cover it. There was a question about the if the first project that was talked about for the workforce data, if that was on the water board's GitHub site, and Devin had responded that it is on GitHub, but it's on the Cali, PA Racial Equity Workforce GitHub, and she put the link in there. And another question, also from Scott, was for David and Michelle. Did you explore geocoding options within R?
Yeah, so maybe I can try to answer that, and then I might pass it off to David. But yeah, when we first looked into doing the geocoding process, we looked at several different options, both inside and outside of R, and I think we eventually stumbled upon that geocoding toolbox, which was developed by our GIS unit, and we decided to go with that for various reasons, but also because there are some concerns about, like, making sure that we didn't have to do additional licensing and paying for like additional services, which sometimes can be attached to maybe not some of the open source tools, but some of the more proprietary web-based tools that are out there. But I think David did also look a little bit deeper into some R options, so maybe he can add a little bit more about that.
Yeah, I think Michelle covered it pretty well. We did look into using something like Google, but I think that does have some limitations if you're going to actually use it for work that you're going to publish. So I think we might have to pay or something like that. So we wanted to avoid that. We did think about using some other open source packages through R. I think there's one through or associated with OpenStreetMaps. And one thought that we had that we just didn't really get around to is actually running those addresses through a couple of different geocoding tools and then comparing them just to kind of get a little bit more confidence. And we just didn't get around to that, but that's kind of another avenue that we were thinking about maybe exploring in the future.
Thank you. And then there's a question, it came in later, so I think it's to Michelle and David. What type of programming languages were involved?
Yeah, so I can take a stab at this. So we used, I would say, two primary programming languages, both R and then Python. And I think I would say we used it more than Python because it was used in kind of several different phases, whereas Python was just used during that processing phase. But yeah, I'd say those are kind of the two primary ones. We did consider using several other platforms, like, for example, both Alexis and myself have a JavaScript background, so we did consider possibly using a JavaScript reporting tool. But in the end, we went with R Shiny, which uses the R programming language. And I don't know, David, if you have anything to add with that.
No, I think that pretty much covers it. Yeah, it was mostly, well, all of the work that I did for this project was in R.
Thank you. And I had a question. Both groups talked about finding these packages, our packages that did X, Y, or Z. Where do you find our packages and how do you know what they do?
I guess I can take a shot and let others jump in as well. I don't know if there's one good answer. I think as you get more accustomed to working with R, you kind of pick up different sources. There's a lot of really good websites and training that will kind of lead you to different resources. And I know some folks even like to use like Twitter to follow different people who are involved with R. But I'd say really starting out, you don't have to worry too much about it. The main sort of group of packages is called the tidyverse, which kind of includes a lot of the really main packages that are most often used. And they're probably like 90% of what I use when I'm using R. So yeah, I don't know if that's a great answer. I'm sure others can add a bit more to that.
I think, yeah, echoing that similarly. And I think some people were putting in the chat like Stack Overflow and just searching what you want to do. And then like the packages will follow. Like I've done things for my non-racial equity work, just my duty statement stuff. And I will just like search. I was trying to find like title, how to modify title data. And there's like a group of packages called like tides. And people make packages for all sorts of things, so it's not always exactly what you need. So sometimes it is easier to just do it yourself. And some people don't even really use like the tidyverse. It's pretty common, but I know some folks just use base R, and that's just how they learned, and that's what they prefer. But there's a package out there for pretty much anything. And then you can also write your own functions if you can't find a package that suits your need. That's also possible. So
Okay. And then there was a question about was our programming easier? And I'm guessing that might be a preference thing that Michelle was talking about. That people in your group had different preferences. But do you want to say anything more about that, Michelle?
Yeah, I think you're totally right about that, Jarma. I think kind of the whole like, which programming language to use, that comes down to a lot of factors. It could be maybe, just using whatever you first learned, whatever you're most comfortable using, what you're most familiar with. But it's true too that like certain programming languages, they kind of have certain strengths and weaknesses compared to other programming languages. So R in particular is very good if you're doing any type of statistical work. And they have a lot of packages for that, a lot of support for that. And compared to some other programming languages that might not have that same support. But in terms of like the actual difficulty and what's easier and what's harder, I think for me, I would say that between like R and Python, for example, I wouldn't say that one or the other is harder or easier to use. I would say they're kind of the same, and it more follows along in terms of like what's the purpose, what are you trying to do and accomplish with using that programming language. So that's just my take on it.
Thank you. I was having some screen difficulty, but thank you for continuing. And here's a more technical question, I think. Do you write Python code in RStudio, now known as Posit? So does anybody use that technique?
So I can only speak for myself. I do not write Python code in RStudio, now known as Posit, but I have heard of those recent developments that RStudio or Posit is making, and I'm very kind of eager and excited to try it out. But I currently do not use RStudio. I use VS Code.
And I guess if we do have, for those at the water board, if you're in the water data community teams channel or teams team, and there's an R channel and a Python channel. So those could also be a place to go for information and assistance if you're running into problems. Are there any other questions for our presenters today? All right. Well, thank you all for joining us, and thanks very much to our presenters, David, Michelle, Leah, and Devin. And as noted, we will be posting the recording as well as the slides with the links and the details on the College of Water Informatics webpage. So you can look for them there. And I hope you've enjoyed today's presentation, and we'll hopefully see you soon.
Looks like there's one more question in the
One more
chat.
question. Oh,
Yeah.
last about the is there any data coding training that you'd like to see offered at the water boards? So I think that's maybe for everyone participating, so that we can then try to get those trainings made available to all to take advantage of. So yeah, if you are interested in that, please add that so we can try to provide that kind of training or work with the academy to do so. Thanks, Scott.
I think that question also links, sorry, Jarman, I just wanted to note to the data literacy survey. We asked questions about data and coding training, and your feedback is used. And so it's really important each year, if you do see that, to participate so we can notate the courses and training that you want to see offered, because I think we all feel like there are quite a few that could be or different interests. So please participate.
And then there was a question we did put out the data literacy survey earlier this year, and the question is, are the results ready yet? And somebody is putting them in a visualization just to compare with the last time we offered it in 2019. And so we will be making those available probably in the first of the year. But thanks for asking. I think that's it. So thanks again. And we look forward to seeing you in another workshop in the future.
Thank you.
Thank you.
Everyone.